Hi, my name is Ron Fieldhouse. I'm the Chemistry Curriculum Specialist at Pasco Scientific. Today I'd like to talk to you about the ORP, or the Oxidation Reduction Potential probe. Sometimes it's also known as a redox probe. It measures the ability to oxidize or reduce in a solution. I do have three solutions. The first one is deionized water. Placing it in there, I get a reading of about 266. That means it's not very oxidizing or reducing, as you'd expect deionized water to be. Since this was deionized water, I'm not going to bother rinsing it. I'm going to put it straight into my sodium chloride solution, my salt solution. And you can see it's reading about the same, so it's also not very oxidizing or reducing. I'm going to rinse this off before I place it in my next solution, which is potassium permanganate. Potassium permanganate is a known aggressive oxidizer, so I would expect to get significantly higher readings by placing it in there. And yes, I can see that I'm about 513 or so. So roughly, just you can run down solutions and measure their ability to oxidize or reduce simply by placing it into several solutions. What I'm going to do next is do a titration using the ORP probe. Here's our titration setup. The actual concentrations in the process is described in our Advanced Inquiry Chemistry Manual. It involves a syringe with the iodine in it, two stopcocks. The top one is set for flow rate. The bottom one is simply on and off. It drops through the drop counter. This whole thing has been calibrated previously using our Spark program. This is our ORP probe that I showed you a moment ago. I installed a magnetic stirrer on the bottom of it. Be careful that your solution does cover up the bulb at the very bottom of the ORP probe, otherwise your readings would be off. I'm going to start my titration already. There I see the drops. I see the drop counter blinking on and off, which means that it is getting a reading. Once the students are done with this titration, they can determine the number of moles of vitamin C inside of this solution. The chemistry manual then goes on to suggest that the students can create their own inquiry-based scenarios. For example, they could discover, does frozen vitamin C have the same vitamin C content as fresh? Does Gatorade have more vitamin C than some other juice? Do fruits have more vitamin C content than vegetables? So this manual allows them to move past the prescribed lab into a more inquiry setting. And we're almost to the equivalence point. And I can see it starting to rise. And our titration is just about complete. So thank you for watching. I hope you do this experiment with your students and allow them to explore chemistry on their own. Thank you.